Okay, welcome back to day 2 of summer school geometry. In this module, we're going to be talking about how to prove if two triangles are congruent. And the two methods we're using today are side angle side, SAS is how it's abbreviated, and side side side, which is abbreviated like this. For the side 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 postulate, let's say we had these two triangles, and I'm going to sketch it like this. So there's the first triangle, and I'll label the corners A, B, C, and I'm going to draw another triangle. And it's going to look almost the same. And I'll label it D, E, F to indicate that it's a completely different triangle. Okay, so if I knew the side lengths of these two triangles, I could tell whether or not that they were congruent or not. So congruent means that two things are the same size and the same shape. So the way I would tell if they're the same size and same shape is if I knew what the side lengths were, for example, here. And I'm going to indicate that using these little marks. So let's say that AB, this segment here, AB, and DE were the same length. Then I know that those two sides are congruent. And if I continue to go around and I saw and I measured BC and EF, those two were the same, and then I did the same thing for AC and DF and saw that those were the same. Now I see that all the three sides of this first triangle ABC are the same lengths as the sides of this other triangle DEF. This is side, side, side because I see all three sides are congruent to all three sides of this other triangle here. So then I can conclude by side, 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 and we write it like this, by SSS triangle ABC, and the congruent symbol is an equal sign with a squiggly on top of it. So triangle ABC is congruent to triangle DEF. That's how we write that. We can only use this if we know all three sides of each triangle and we know that they are congruent to each other. Then we also have a different way to approach this. If I had another example where, let's just say I had these two triangles that look like this. But now let's say that instead we measured an angle. So let's take this top angle here, and let's take the top angle here. Let's say we measured both of those and they were the same. And then we measured the two sides around that angle. So I'm going to take this side and this side. So here's a side and here's a side. They're both the corresponding sides. And then I take a different side over here. Now this is called side angle side because if you notice on both triangles, all three of those parts of the triangle are connected to each other. So side, angle, and side. Notice how they're all connected to each other. The angle has to be in between the two sides that are joined right here at this angle. So this is what we call side angle side, and it has to be in this order like that. Side angle side. See how I can join them together like that by side angle side. And let's name these again, A, B, C, D, E, F. And we can say triangle ABC is congruent to triangle DEF, just like that. And this time, instead of side, 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 we used side angle side, side angle side. Okay, so that's how we show these triangles are congruent. So now let's look down here at these examples and identify what the method is. Is it side, 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 or is it side angle side? So if I look at this first example, I notice that all three sides are labeled, all three sides are labeled. This is going to be side, side, side. And now I need to write triangle, it says ACB. Whenever we write the second triangle that's congruent, we have to write the letters in the same order. So if I did ACB in this order, so I'm going to draw an arrow like this and then like this, I need to use the same order for the second triangle. So like this and like this. Triangle we start with y, we go up to x, and we go down to z, just like we did a, c, b, y, x, z, like that. Okay, so the order of the letters matters here. Now let's talk about the second one. We notice we have two sides and an angle in between them. Okay, the angle is connecting the two sides here. And the same thing goes down here. So this is going to be side, angle, side. And now I have to look at GHF. So GHF goes like that. So we started at G, we went up to H, and down to F. Now, I need to kind of think a little bit differently about this because the two triangles aren't drawn the same way. I started at this angle here, and I ended up at the right angle. So I know for this triangle, I need to start where the corresponding angle for G would be. Since this looks kind of like a reflection, W is where I would start. I would go to B, and then I would go down or up here, in this case, to the right angle. So WBR, triangle WBR. All right, let's keep going here. All right, let's look at this right here. I have an angle on each of them, and I have side, side. So naturally we would think side, angle, side, but look closely here. This angle is not connecting the two sides. See how this angle P is not even touching this side YE right here? Same thing over here. Angle L does not touch KS. Since it doesn't do that, this would not work. It's neither side, 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 nor side, angle, side, because if it were to be side, angle, side, I would need the angle right here to be the angle that's marked in the triangle, but it's not, it's down here. So this would not work. So I just put not applicable for number 3. All right, number 4, a little bit faster, side, angle, side. We got RED. So that means the other triangle should be BTA. Then we've got over here, we have two sides marked on each triangle, but then they're joined together right here, RK. And if they're the same side for both triangles, we know that they have to be the same length for both triangles. They're sharing this side right here. They have to have the same thing. So this is going to be side, side, side. All right, and then last right here, this looks like it's going to be neither side, 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 nor side, angle, side. This is actually not going to work because it's angle, angle, angle. That's not a rule here, so I'm going to put not applicable. All right, so there's your examples for day 2. In summary, we talked about side, 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 angle, side. Okay, so now go ahead, go back to Canvas, click on the module, and go ahead and complete the assignment for today. If you do have any questions, as always, you can email me. It's right here. Let me know if you have questions or you need help.